Hey Gears, Coach Fitz is here. We're going to take a look today at Geometer Sketchpad and how we can use it to estimate the cost of doing some 3D printing for the B-Box prototypes. This particular sketch is set up for a rectangular prism where this is the front of the prism, this is the right side, the left side, the top, the bottom, and the very back. Rectangular prisms have 6 sides, 6 faces rather. We see all 6 represented here. The dimensions were determined by these sliders, and as the slider is changed, the sketch will update itself, and so will all the calculations that rely upon that dimension. This sketch was designed for an optimization process where we could explore what dimensions are possible with a price limit. So in this case, we set our price limit of around $20, which is what this calculation represents. That calculation was reached by determining the surface area of each face and then determining the width, which is also a slider. As you make the box thicker and thicker, it costs more and more to produce it. In our case, we looked at a thickness of around 0.6 centimeters, which is possible with, it's about 1/4 of an inch. What we determined is once you know the total surface area, you can find the volume using that width. So what we're basically assuming is that when the object's printed, we just don't worry about the overlap. So it's a little bit bigger than it would be in real life. Based on the total volume, we can calculate the mass by multiplying the volume times the density. So once we know the mass of our object, we can figure out the cost to produce it based on the cost per unit of weight, which is how the material is sold to produce it. So in this case, we figured it's around $20. You can ignore the centimeters here because those units are carrying through from the sliders, and that answer should really be in dollars. To help you guys think more carefully about what these dimensions correspond to, they were converted from centimeters back into inches so that things would make a little more sense. So in this case, this is a rectangular prism, and if we wanted to, we could explore, could we make it a little bit wider and keep it around the cost we wanted? And we can see we're starting to go over cost there, so we can slide it back. And it turns out that this is really as big as we can get it with this design. Now, in terms of innovating, we know that we need to consider some other shapes. The first B-Box we saw was made of a rectangular prism. So the question that we started with thinking is, well, what would it be like if we had a triangular prism? And we're going to explore that a little bit right now. So let's start making just a little sketch of what a triangular prism is going to look like and how it's going to be related to our B-Box. So in the case of a triangular prism, we know it's got a triangle for its front. It's going to have a couple of sides. We'll call this the right side. As we're facing it, our right hand would touch it. The left side would be back over here. If this is the front, the back would be over here, and the bottom would be up over here. The advantage of this design, you could probably already tell, is it doesn't have nearly as many sides. If we make a net for a triangular prism, we've got our triangle, we've got our right side, we've got our left side, we've got our bottom, and we've got our back. Some people think this looks like a mouse. Label front, right, left, the bottom, and the back. And we can see here that these sides are all equal. And these sides here are all equal. And we know that these are this way because we're making this a regular triangle. And this side here is going to be equal to the side of the triangle because when you fold it back up, these are going to connect back over with that side there. And this is going to connect with that side there. So hopefully this will help you think about taking a triangular prism, unfolding it so that we can start considering its surface area. Now, doing it like this, we could spend a long time trying to make calculations, which is why Geometer Sketchpad is so helpful. So we're going to start by creating some labels. And the first label we'll create is the length of the radius of the circle to make our triangle. And we're going to come to that in just a second as to why we're, you know what, let's not do that. Let's just make a slider for the length of the triangle. So making a slider is not a very difficult thing to do. All we're going to do is we're going to lay out a line segment. We're going to put a point on that line segment. And then we're going to measure the distance between these 2 points. And we're going to put that right in there. And I'm going to move the whole line segment over here. And now you can see that as I slide this point, it updates my line segment. Now, in order to make this an interactive drawing, we are going to use this as an input for other things that we do. It's going to be a lot of translational and transformational geometry. The next thing we're going to need is the length of the prism. And again, we're going to take another slider. So we're going to take a line segment. We're just going to put a point on that line segment. We're then going to measure that distance. And we're going to drop that right next to our label. So, as we start taking a look at this, I'm going to put a point on the screen. I'm then going to select this distance, and I'm going to go to Mark It. And what that's going to do is I'm going to translate a point forward. And it's going to put it that marked distance. And I don't want it at 90 degrees. I want it at 0 degrees. And here we go. This is the base of our triangle. So if we know that that's the length of a side, we can mark this triangle here. Actually, it doesn't matter which one we do. We can start at the beginning. We're going to mark this point as a center. And we can pick this point, and we're going to rotate it, transform, rotate. And it's not going to be 90 degrees, but it's going to be 60 degrees to make our regular triangle. And then we're just going to complete the sides here. And when we select all of those points, we can construct a polygon interior. And by selecting the points to make a polygon interior, in this case a triangle interior, we can then measure the area. And let's label that, because we're going to call this our front. And it's going to be important when we're doing three-dimensional geometry to try to keep track of everything as we go. So we can see here that if we change the length of our triangle changes. If we change the length of our prism, nothing happens, because we haven't used that yet. So the next thing we're going to do is we're going to move this triangle to give ourselves a little room to make our drawing. We're going to mark this distance. And then hey guys, now that we've finished the front face, the next easiest face to make is going to be to make the bottom. And I'll show why that's the case in just a second, because some of the other sides are actually pretty tricky to make. But it won't take long, and I'm sure you'll understand it. So the bottom side, let's select this point here, and we're going to, we want to mark that distance. And we're going to translate this point, that marked distance, and we want it at an angle that is going, let's see, 90, we want it to be negative 90. Because we know each of these is going to be rectangular prisms for the sides. So we know that that's going to be 90 degrees. And it's negative 90 because it's referenced to this point here. With this point here being 90 and that angle there being 0. So this would be negative 90. We could, if we wanted to, probably refer to it as 270 as well. And if you think back to a circle, 270 would be the other direction. I like you guys thinking simple, so negative 90, hopefully that'll work for you guys. And I'm going to do the same thing over here. I'm going to go to Transform, Translate. Negative 90 is saved, and that is perfect. So now what I'm going to do is I'm going to go ahead and fill in the sides. I mentioned earlier that having these segments drawn in makes it a lot easier to see the shape when it's done. So I'm going to select these points. And color coding is good too, so we could go ahead and do that. So we are going to construct a quadrilateral interior, and we're going to measure area. And now we can check that if we change the length of the prism, that updates automatically. It's not changing the base, it's just changing how long the triangular prism is. And if we want to change the color code on this, we can double click it. We can take a look at a different color. Maybe we like that color better. That looks like it's going for, oh, there we go. Click OK. Let's see here. All right, well, we'll come back to that. Maybe one of you guys can figure out how to change the color. I'm doing this on a Mac, and it's not abundantly clear to me how to best do that. So I'm going to make the back next, because the back is also pretty easy to make. So I'm going to grab this point. I'm going to mark this center. Oops, I'm going to select it first. Mark the center, and now we are going to rotate that point. Notice how far away it is. And we're not going to rotate 60 degrees. You guys can probably guess it's going to be negative 60 degrees. And we're going to go ahead and fill that in with some line segments. And I'm sure you've guessed by now, we're also going to construct a triangle interior. There we go, and then we're going to select that interior and measure the area. And we can see that it's the same as the front, and if I adjust it, it adjusts automatically. And in this case, the bottom's adjusting because it's connected to the length of the triangle. So that looks great. So now for the tricky part. So this is the front. We want to make the right side. And in order to make this a little more clear, why this works the way it does, I'm going to go ahead and select this line. I'm going to put in a parallel line. And we know that we want the side that's coming off of here, we know we want this angle to be 90. So to some extent the question is, well, what is this angle to make this angle 90? And remember, this angle here is 0. And so one of the best ways to explore this is, let's go ahead and just select a point, select the line, select a point. We're going to construct a perpendicular line. Oops, it's not where I wanted it. Let's get rid of that. Select this point and this side and construct a perpendicular line. So now I know that that angle's 90. So I could just measure this angle to find out what it is. And that's one of the great things about Sketchpad is you don't have to understand everything about geometry. You can go ahead and just figure out some stuff by making your drawings. Let's measure that angle. And that angle is 30 degrees. Now we could have, if we had wanted to, some of you guys are probably doing this already in your head. You know this one's 60. You know this one's 90. So 90 and 60 are 150. So that one would have to be 30. So I'm going to get rid of those. I'm going to select this point. I'm going to mark it as my center. I'm going to go ahead and mark the length as my distance. And I'm going to grab this point and I'm going to translate it. I'm going to go my marked distance and it's going to go 30 degrees. I'm going to mark it over here. It's 30 degrees. I'm going to fill in my sides. And I'm going to make my quadrilateral interior. Construct quadrilateral interior, and then measure the area. And that is my right side. So far, so good. And now I have to do my left side. So I'm going to go ahead, select this point, and I'm going to translate. And if on the right it was 30, you guys are probably guessing maybe on the left it's minus 30. And what's happening here is it's referring to this point here, and we want this angle. So we know it's 30, we know, so 30, 90, we want it going off in that direction. So 30 and 90 is roughly 120. And that doesn't look quite right. So let's repeat it on this side. Let's grab our parallel line. Grab a line, grab a point. Construct parallel line. We're going to grab this point, and we're going to construct a perpendicular line. We're going to put a couple points on there to measure the angle. We could probably guess that this angle here is going to be 30. You think? Kind of looks like it's 30. It is 30, no big surprise. So when we go to construct this side, let's try 150. And that looks perfect. Because it's up 30 from here, it's measuring it this way. Let's do another one over here. Let's make our sides. Oops. There we go. Select our points. We're almost done. We're going to construct quadrilateral interior. Let's measure the area. And this is going to be the left. And so that's the hard part. We've made our drawing. It will update automatically. And let's just test it real quick. Let's change the length of our prism. That looks good. Let's change the length of our triangle. Oh, that looks good too. So the next step is to calculate the total area. So we're going to go to calculate, and we're going to say this number plus this number plus this number plus this number plus that number. I'm going to click OK. So that gives us a total surface area. Now we're going to make another slider for the width. And this is going to determine how thick the sides are in the 3D print. So we're going to measure this distance here. We'll call that the print width. That looks pretty good. Now we're going to calculate the volume. So the volume is going to be the surface area spread out over that width. So the calculation for the volume isn't too bad. We're going to measure, calculate. We're going to grab the area. We're going to multiply it by the volume. And that will give us this volume here. Now, it's accurate, because the width is in centimeters, the area is in centimeters, and so this is perfect. And in fact, a lot of the printer programs like it in metric units. So now the question is, we need one more slider for the density of our material. and that's because PLA prints at a density of 1.25 grams per centimeter cubed, and ABS plastic is a little heavier still. So let's add our density of material, and we're going to make one more slider so that we can consider it in either ABS or PLA. So let's measure that distance. Okay, and I'm going to slide that down to 1.25. That's close enough. 1.27, it'll work. It's an estimate. So now we need to calculate our mass of material. And the way we're going to do that is pretty straightforward. If you guys remember from Math Counts, we'll leave that up. That's fine. We've got a volume in centimeters cubed. I want to convert that into grams. The density shows me the relationship between the volume and the mass. So what happens here is whatever my units of volume are, they cancel out, and I'm just left with my grams. And this here is my density, and it's an equality. It's like multiplying by 1, and what it's telling me is for every 1 unit of volume, I have this amount of mass. So if we go back into Sketchpad, this is a pretty straightforward calculation. We go to Measure, Calculate, we take our volume, we multiply it by our density, and that gives us our mass. Now this would be a mass in grams, okay? And now, you probably guessed it, one more slider, because the cost for our materials is different. So let's go ahead and measure that distance. We're going to make that our cost per kilogram. Generally speaking, the printing material is sold in kilograms. And in this case, 1 kilogram of PLA is around $18. So put it right there. And ABS is around 30. So we can make that poke out just a little bit further. There we go. We got 18. Okay, so now if we want to calculate our total cost, and the way we're going to do that is the same idea. Let's just go back and look at the calculation very quickly. So we have our mass, which is in grams, and we're going to multiply that by, in this case, it's 1,000 grams, because it's 1 kilogram, by our price, which is, in this case, our price is roughly $18. For 1,000 grams, our grams are going to cancel out. This, like density, is an equality. It's telling us this relationship of dollars is equal to this relationship of mass, so that we can use these relationships to convert units from grams to dollars, and that's what we're about to do. So we're going to do a calculation, and we're going to say this mass of material times this price divided by 1,000, because it's in 1,000 grams or in a kilogram, and it would tell us that this print would cost us $6. So now we wanted to optimize this. We knew we wanted it to be around $20. And what we don't know necessarily is we don't really think in terms of centimeters, and so let's convert back to inches. So length, inches, and we'll create another label that says triangle, prism length in inches. Oops. Okay. So now we're going to do a calculation. So calculate. So we're going to take this length, and if that's in centimeters, we're going to multiply it by 0.39. And we could Google that for a conversion. Convert centimeters to inches, and we would get something like that. So we click OK, and that tells us it's roughly 2 inches. And we're going to do the same thing over here. Calculate this length times 0.39. It's going to give us 1.37. We know those are inches, even though it says centimeters. And just to be sure that everybody's clear, if we've got, let's say, x centimeters over 1, when we convert it, what we're doing is saying, okay, 1 centimeter is equal to 0.39 inches. So our centimeters cancel out. So we multiply our centimeters by 0.39 to get our answer in whatever y inches it is. And again, this is another form of an equality. In other words, these are related to one another, so that multiplying by this equality is a lot like multiplying by 1. But you got to know what units you're going to get when you're done. So we'll come back, and it's saying that we've got roughly 2 inches by 1 inch. So that's not nearly long enough. So let's make this a little bit bigger. To fit a bee in there and feel safe about it, we'd have to go to maybe 5 inches. And the length of the prism, to get 2 chambers in there, we'd have to go out to, we could probably do 8 inches. And that's overpriced. But this is way thicker than we had intended it to be. So let's slide this back to around 0.6. And we see here, oh, that doesn't cost very much to print at all. In fact, we could make it longer or taller if we wished, and fit it well within our budget. So that is how you would make a triangular prism work for. Let's make the length of it out near 8. And if you run out of room on your slider, just go ahead and make it bigger. So this would cost us about $15 to make this triangular prism shape. In any case, learning how to optimize things is a big part of what engineers do professionally. So we knew we had a target of trying to keep our print at around $20 in price. We were exploring some different shapes that might enable us to do that. We couldn't find an easy way to do it online, so we created our own way of doing it. It starts by building a sketch in Geometer Sketchpad where the length of the triangle and the length of the prism are things that we can manipulate. We then calculated the surface area of our prism and then said that the volume of the printed shape would be a function of that surface area and the width of the printed shape. We know the density of material, so we can calculate the mass. Once we know the mass, we can calculate the cost from the unit price, and then we can do that to estimate how much it would cost for us to print this in terms of material. So I hope this helped. I know we're going to look at a couple of other shapes, some shapes that might even be more interesting to do. I think the hardest part of this whole process was understanding what angle to make these at. So don't forget when you're making your own drawings that if you're stuck and you're not sure, go ahead and add some parallel lines, perpendicular lines, whatever it is you need to be able to figure out how to make your sketch. All right, guys.